What's going on, guys? Coach Carr here, bringing you another video. This one is on page 3 of your notes, so it will be number 5 and 6. So the success criteria for this one is you'll be successful when you know the formula of the area of a sector and can use it to solve problems like the ones you're about to do. Now, the learning target is the same as the last one, where we derive using similarity the fact the length of an arc intercepted by an angle is proportional to the radius, and define the radian measure of the angle as the constant proportionality. Derive the formula for the area of a sector. Okay, so on page 3 it says, we're looking at number 5. It says, in the diagram, the shaded region has an area of 48 pi units squared. If the measure of the central angle is 60 degrees, what's the exact radius of the circle? So if you notice, we have the word exact all capitalized. So the reason for that is that's telling us we want to keep it in simplified radical form. So when we have our answer, we are not going to have it as a decimal. We want to keep it in simplified radical form. So the formula that we would use whenever we're dealing with a sector like we have would be the area equals the angle times pi r squared all over 360. In this case, they tell us what the area is. So instead of the A, I would have 48 pi. And that's going to equal, now they told us the angle. They told me that it was 60 degrees. So 60 pi r squared all over 360. Because remember, we're trying to find the radius. We're trying to find this here. So now, first thing I would do if I were doing this problem is I want to get rid of these pi's. So right now, the pi over here is multiplying with the 60 and the r squared. So the way you get rid of multiplication is through division. So I am going to divide by pi to both sides. When I do that, it cancels out here and here. So when I do that, I now have 48 equals 60 r squared all over 360. Now I'm trying to get that radius squared by itself. So the way we're going to do that is I'm going to take this 60 and over 360, and I'm going to flip them. The whole reason I do that is so I can do the same thing to the other side. When I do that, it cancels out here and here and there and there. So the whole point is to cancel it out on this side. So we do it to this side as well. When I do that, the numerators multiply together. So 360 times 48. And that's going to get me 17280. So 17,280. And then 60 times 1, because 48 is over 1. We get this over 60 equals r squared. When I divide this number divided by 60, what I get is, I'm going to continue it on up here, 288. So 288 equals r squared. Now the way we want to get rid of a square is with a square root. So the square root of 288 equals r. Now, this is just not in the simplified radical form. So what I want to do is do that. So I'm going to do that off to the side. So a number that can go into it would be 24 and 12. So 24 times 12 equals 288. A multiple of 24 could be 6 and 4. A multiple of 12 could be 6 and 2. So let's say I continue it down. 6, 3 and 2, 4, 2 and 2, 6, 3 and 2, and 2 can't be broken down anymore, so I'm just going to bring it down again so they're all in the same row. So something that I see that a lot of people do is they go back up whenever they're doing this. Maybe crossing them out could help you with that. So now we want to look at our multiples of the same number. So any pairs. So I have a pair of 2's right here. I have another pair of 2's right here. And I also got this pair of 3. So anything that you have a pair of goes on the outside. So I have a pair of 2. I have another pair of 2. And I had my pair of 3's. Whatever's left over stays on the inside. So this here, this 2, was left over. So that's what goes on the inside. So now, 2 times 2 is 4. 4 times 3 is 12. So I would have 12 times the square root of 2. So if this were to be simplified, I would have 12 radical 2 equals r. And that would be the exact radius of this circle. Okay, so now we're looking at number 6 on page 3. It says, in the diagram, the radius of the circle is 4 times the radical 2 meters. And the area of the shaded region is 44 over 9 times pi meters squared. Find the measure of the central angle, angle AOB. So I'm just going to label the stuff they told me already. They told me that the radius here is 4 radical 2. And the area of the shaded region is 44 over 9 times pi. So the area of this here is the 44 over 9 times pi. Find the measure of the central angle. So in this one, again, we are going to be using that formula of the area equals the central angle, which is what we're looking for, times pi r squared all over 360. So instead of the A, we actually are told what our area is. So our area for this one is 44 over 9 times pi. And this is equal to, now we don't actually know what the degree is, so I'm going to keep it as that symbol. And we got pi with a radius of 4 radical 2 squared all over 360. So first thing I'm going to do is I'm going to try to get rid of the pi. So right now this is multiplying with these two things, the angle and the radius. Now the way we get rid of multiplication is through division. So I'm going to divide by pi on both sides. That is so it cancels out for both of them. So what you have now is 44 over 9 equals the angle times 4 radical 2 squared all over 360. Now, some of you might be intimidated by this 4 times the radical 2. I'm going to show you what you need to do in order to find out what the number is going to be. Whenever you have a number on the outside, so the number on the outside, when I put it back in, is just multiplying by itself. So if I multiply this by itself, 4 times 4 is 16. So inside, really, I have 16 times 2, because I moved this back in there. So 16 times 2 is 32. So right now, this is all under a square root. If I were to square this, it just becomes the number that was inside of there. So whenever I do this, so now I would have 44 over 9 equals the angle times 32 all over 360. Because again, whatever the square root is, if I square it, it just becomes the number that's inside of it. So what we are going to do now is multiply each side by this reciprocal, because we're trying to get the angle by itself. So what I'm going to multiply each side by is 360 over 32. So same thing to this side. 360 over 32. Now, numerators multiply together. So 360 times 44. I would get 15,840 over 32 times 9, which is 288, equals, now this would get canceled out, and this will get canceled out. So this would just equal whatever the angle is. So 15,840 divided by 288 equals 55. So this angle inside here would be 55 degrees. Thank you so much for watching. That's the end of this video. So make sure, again, that you're getting all your exit slips turned in that you need to.